Hello and welcome to yet another video of Cornerstones of Math. Today's problem is rather simple. When x can have real values, we need to find the maximum and minimum values of the function y equals x over x squared plus x plus 1. The thing is, there exist many methods to solve this problem, and I suggest you to pause for a while and think about as many methods as possible before actually engaging the problem. And for those of you who just want me to explain them for you, let's dive right into the first method. And let us start with the simplest and least advanced method of all, the discriminant method. The key here is to notice that both x and y can have only real values, and the highest degree you can find is this x squared, the quadratic term. So how can we utilize this knowledge? Well, first, let us rearrange the given relation into x squared plus x plus 1 times y is equal to x. If we rearrange this into the descending order of x, we obtain yx squared, then plus y minus 1 times x plus y equals 0. We can think of this as a quadratic equation of x. And since x is real, this quadratic equation must have real roots. Therefore, its discriminant must be non-negative. So the discriminant delta is given as y minus 1 squared minus 4y squared, and this must be non-negative. And if we rearrange this, we obtain 3y squared plus 2y minus 1 is less than or equal to 0. Which can be factored into 3y minus 1 times y plus 1 is less than or equal to 0. So y is greater than or equal to negative 1 and less than or equal to 1/3. From here, we know that the maximum value of y is 1/3 and the minimum value of y is negative 1. So this is our answer. The second method is to use the famous inequality about arithmetic mean and geometric mean. The inequality itself is very famous and straightforward, but here's the part where we have to approach a bit carefully. The arithmetic mean geometric mean inequality only works for non-negative numbers x and y. Since our function is defined on entire real numbers, we need case division. So first, let us only consider the case where x is positive. Then we rewrite the given function as 1 over x plus 1 plus 1 over x. So 1 over 1 plus x plus 1 over x. And we apply the arithmetic mean geometric mean inequality at this x plus 1 over x part, which gives x plus 1 over x is greater than or equal to 2 times square root of x times 1 over x, so just 2. The equality holds when x is equal to 1 over x, that is, when x is equal to 1. This gives 1 plus x plus 1 over x is greater than or equal to 1 plus 2, so 3. And if we take reciprocal of it, we obtain 1 divided by 1 plus x plus 1 over x is less than or equal to 1/3. Here, when we are taking reciprocals, we also obtain this greater than 0, which makes sense if you think about it. So we have y is greater than 0 and less than or equal to 1/3. Next, let us consider the case where x is negative. Here, we just let t as minus x, then t is positive, and since x is equal to minus t, we can write our function as 1 over 1 minus t minus 1 over t, so 1 over 1 minus t plus 1 over t. Here, since both t and 1 over t are positive, we can apply the arithmetic mean geometric mean inequality, which gives t plus 1 over t is greater than or equal to 2 times square root of t times 1 over t, so 2. And obviously, now the equality condition is when t is equal to 1 over t, so t is equal to 1, or x is equal to negative 1. And let us obtain this expression. So first, 1 minus t plus 1 over t is now less than or equal to 1 minus 2, so negative 1. And if we take reciprocal, 1 over 1 minus t plus 1 over t is now greater than or equal to 1 over negative 1, so negative 1. And here we also automatically obtain this less than 0. So in this case, we have y is greater than or equal to negative 1 and less than 0. Now this case is rather trivial, but we actually have to separately consider the case where x is equal to 0, because in this case, we cannot divide the numerator and denominator by x. In this case, y is simply equal to 0. Therefore, from our case divisions, we know that the maximum value of y is 1/3 and it happens at x equals 1, and the minimum value of y is negative 1 and it happens at x equals negative 1. The last method is also kind of obvious if you learned calculus. We use the mighty power of calculus to find the maximum and minimum values of the given function. So if we take derivative using the quotient rule, we obtain derivative y prime is equal to 1 times x squared plus x plus 1 minus x times 2x plus 1 divided by x squared plus x plus 1 squared. So we obtain minus x squared plus 1 divided by x squared plus x plus 1 squared. So we have 1 plus x, 1 minus x divided by x squared plus x plus 1 squared. Notice that the denominator is always positive and never becomes 0 because this part is always positive. And we can notice that the derivative becomes 0 at x equals negative 1 and 1. Moreover, you can notice that limits of y as x approaches either positive infinity or negative infinity are both 0, meaning that y equals 0 is an asymptote as x approaches either positive infinity or negative infinity. From our derivative, we can fill out this increase-decrease table of the given function. So first, the derivative is 0 here, and positive here, and negative here. This means that the function decreases here, increases here, and decreases here. And the value at x equals negative 1 is negative 1, and the value at x equals 1 is 1/3. The cool thing about calculus method is that we can obtain the entire graph of the function. And of course, we can also find out that when the function becomes maximum or minimum as well. Anyway, from this result, we have maximum value of y is equal to 1/3 when x equals 1, and the minimum value of y is equal to negative 1 when x is equal to negative 1. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.